Hi friends! Today we will discuss about transistors in computers and logic gates, especially in gate, or gate, and not gate. So, this is a computer. We usually use computers for various purposes. But, have we ever wondered, how can a computer understand our instructions? Let's discuss it together. Computers are made up of many small components that work together. One of the most important components that makes a computer work is the transistor. This is what a transistor looks like. Transistors are semiconductor devices used as amplifiers, as circuit breakers and connectors, switching, voltage stabilization, signal modulation, or as other functions. Transistors can function like electric taps, where based on their input current, BJT, or input voltage, FET, they allow very accurate electric flow from their power source circuits. In general, transistors have three terminals, namely base B, emitter E, and collector C. The voltage at one terminal, for example the emitter, can be used to regulate the current and voltage that will be amplified through the collector. In addition to being used for transistor amplifiers, it can also be used as a switch. The method is to provide a large enough current to the transistor base until it reaches saturation point. In conditions like this, the collector and emitter are like connected wires or closed switches, and vice versa. If the base current is very small, the collector and emitter are like open switches. Transistors consist of three different layers. Two of them are doped to produce one type of semiconductor, and there is an opposite type, namely N-type, and one P-type or vice versa. How the transistor components work around us and are related to the main function of the component. This component can be considered as two P-type, N-type junctions placed back to back. One is the base emitter junction forward biased and the base collector junction reverse biased. The transistor works when electrons and holes start moving across the two junctions between N-type and P-type silicon. When current flows through the base emitter junction, electrons leave the emitter and flow into the base. However, the doping in this region remains low and relatively few holes are available for recombination. As a result, most of the electrons can flow through the base region and enter the collector region, then attracted by the positive potential. Only a small portion of the electrons from the emitter combine with the holes in the base region, causing a current in the base emitter circuit. This means that the collector current is much higher. Now we discuss about logic gates. Logic gates are the process of processing binary number input with Boolean mathematical theory. As we know, binary numbers themselves consist of the numbers 1 and 0. If it has a true value, it will be indicated by the number 1. Conversely, if it has a false value, it will be indicated by the number 0. Logic gates have the function to perform basic logic functions to form integrated digital circuits. Most logic gates use binary numbers 0 or 1, can also be called true or false. Usually consists of two input values and one output value. AND gate, the first type, is the AND gate. This AND gate requires two or more inputs to produce one output. If all or one of the inputs are binary 0, then the output will be 0, while if all inputs are binary 1, then the output will be 1. OR gate, the second type, is the OR gate. Just like the previous gate, this gate also requires two inputs to produce one output. This OR gate will produce an output of 1 if all or one of the inputs are binary 1, while the output will produce 0 if all the inputs are binary 0. NOT gate, the next type, is the NOT gate. This NOT gate functions as a state inverter. If the input is 1, then the output will be 0 and vice versa.